Okay, these are, you're going to hate these, okay? These are what are called chemistry mixtures, okay? Okay, so we did a mixture with percents with money, okay? Now we're going to do it with chemistry things. It says a scientist wants to make 6 milliliters of a 30% sulfuric acid solution. Okay, here's kind of what this means here. I'm going to draw a little picture here, okay, just to kind of help you out. So the solution needs to be made up from a combination of 20% sulfuric acid solution and 50% sulfuric acid solution. How many milliliters of each solution will be combined to make a 30% solution? Okay, this is confusing if you don't follow the guidelines here. Okay, so at the end he wants it to be 30%, okay, a little under half. He wants 30% of that sulfuric acid. What he's going to do to get it is he's going to take this bucket here, this container, and that's got 20%, so it'll be a little bit less. The rest is liquid, okay? The rest is water, okay? So sulfuric acid, the rest of it's water, okay? And then he's going to combine it with this bucket where he has 50%, so half. Okay, the rest is water. He's going to dump those two buckets into here, and he wants 30% of that to be sulfuric acid. Okay? Now, here's how you want to go on this. You want to make your table. And you got 3%. What you're going to do is take your lowest percent, your highest percent in that order, and then the middle percent. Okay, now find a number 6, and that label's milliliters. So put your label, milliliters, percent, after that. Okay, and then we'll pretty much be good to go. Okay, I don't really necessarily need a bottom label on that necessarily. Okay. Okay, so your percent's 0.20, 0.50, 0.30. Now, how many milliliters do you have? You got 6, but that's of the 30%. That's how much you're going to have at the end. But you want to know how much of that is the 20%, how much of it's the 50%. So x and y, and then I take x times 0.20, 0.50y. And 6 times 0.30 is 1.8. So now, of course, you have a system you can write out. Okay. So x plus y equals 6. And 0.20x plus 0.50y equals 1.8. So I multiply these are 1s. So 0.20, 0.20, 0.20, and then 1, 1, 1. So 0.20x plus 0.20y, and 6 times 0.20 is 1.2. Or no, sorry, 7 point. No, it is 1.2. Okay. 6 times 0.20. I just don't want to put the wrong thing. Yeah, it's 1.2. Okay, and then the bottom, 0.20x plus 0.50y equals 1.8. Let's get these as negatives. Now with decimals, you should not be trying to do it in your head. 0.20 plus negative 0.50, negative 0.3. Okay, then I take 1.2 plus negative 1.8, and that's negative 0.6. Okay, so negative 0.6 divided by negative 0.3 is 2. Okay, now you label that. There's 2 milliliters at 50%. So ml at 50%. Okay, so he's going to take 2 milliliters from this bucket. Okay, 2 of them. And by the way, the 6 milliliters is the 30%. Okay. Then you can either take 6 minus 2, or you can play your little game of putting that in for y. Okay, so 1x, 1 times 2 is 2, equals 6, minus 2, and that is 4. Now 4 milliliters at 20%. So basically what you told people, your audience, is that, okay, we need to take 4 milliliters out of this bucket and 2 milliliters out of that bucket, dump it in, and it'll be 30%. Okay, my next one. That was a crappy job of drawing that picture, by the way. How many ounces of a combination of 20% hydrochloric acid solution and 70% hydrochloric acid solution need to be mixed to obtain 20 ounces of a 50% hydrochloric acid solution? Okay, so with chemistry mixtures, we want this. Okay, draw these kind of boxes. It helps me understand what's going on. Okay, so at the end, they want 50%. Okay, so 50% hydrochloric acid, the other 50% is water. Okay, now they get that by taking a 70%, well over half, mixing it with a 20%. These two buckets are dumped in here, and they want to make 50%. They need to know how many milliliters from each bucket. Well, or not milliliters, ounces in this case, it's ounces. Well, we know the final bucket has 20 ounces. Okay. So put your 3 percentages, the lowest, the highest, and the middle. If there's 3 of them, you got to line it up like that. This just takes the place of what I had as the total. Okay. Okay, now we're talking ounces, so put OZ. Okay. And then your percent. Don't really need a bottom label. It's not really that important. Okay. So 0.20, 0.70. 0.50, and the 20 ounces is the 50%, so 20, and then if I have that, these unknowns are X and Y, so 0.20X, 0.70Y, 50% of 20 is 10, okay, so X plus Y equals 20, 0.20X plus 0.70Y equals 10. 0.20, 0.20, 0.20, 1, 1, 1. So 0.20x plus 0.20y, and that's 4. And the bottom 0.20x plus 0.70y equals 10. Okay, make those all negatives. So add those together, you get, here I'll show you on the calculator because I don't want people trying to do it in their head. Negative 0.5y. Add those, you get negative 6. Okay, and negative 6, it's 12, but I'll show you how. It's 12, okay. Okay, now label that. It's 12 ounces at, all you do is ounces at 70%. Okay, now you can take 20 minus 12, which I'm going to do here to save time, and that's 8. 20 minus, or you could plug it in. It doesn't matter. You get 8 either way. So X is 8, and that's ounces at 20%. So I want to take 12 ounces from this bucket, 8 ounces from this bucket, dump it in. That gives me the solution I want. Okay, I've got 3 more to go. It's 10:20 at night here. Farmer needs 24 gallons of milk that is 20% butterfat. The farmer has a combination of 2 milks, one that's 24% butterfat, one that's 18% butterfat. How many gallons of each type of milk does he need? Okay, now you should kind of know how the pitchers work now. You're taking these 2 buckets, dumping them into that, okay? At the end, what you want is 20% butterfat, okay? I'm not even going to bother with the diagrams anymore, okay? I'm just going to go straight to the table because we got 3 percentages. You take the smallest percent, 18%, you're mixing it with the largest percent, and you need to come somewhere in the middle, which is 20%. Okay, so your unit is gallons and then percent. So and I'll get the bottom. The bottom works itself out on these percent problems. I should have just done it that way on the other problems. 0.20. Okay, so The 24 gallons is at the 20%, so 24. Okay, and then X and Y, because I'm trying to figure those out. How many gallons of each type of milk? How many of the 18% butterfat? How many gallons do you have to dump of the 24%? So 0.18X, 0.24Y. So X plus Y equals 24. 0.18X plus 0.24Y equals, I got to multiply that. 20% of 24 is 4.8. So 1, 1, so I'm going to take these times 0.18, 0.18, 0.18, and then 1, 1, 1. So 0.18X plus 0.18Y, and then I take 24 times 0.18 is 4.32. In the bottom, 0.18X plus 0.24Y equals 4.8. Make those all negative. You don't need to do that in your head. 0.18 plus negative 0.24. When people try to do it in their head, they miss a decimal. They'll put negative 0.6. It's 0.06, and they'll wonder why they get a jacked up answer. Okay, 4.32 plus negative 4.8 is negative 0.48. Divide. Okay, and that's 8 gallons of 24%, or at 24%, one or the other. Now the X, you can just take 24 minus 8 or plug it in, you get 16. Anytime you got 1X, 1Y, you can do that. And that's gallons at 18%. Okay. Next one, you will, if you're taking trig, you will do these problems. So that's kind of what I'm setting you up for. I don't care if you're not taking trig, you are assessed on it. Chemistry class, you need a 1% hydrochloric acid solution, 5% hydrochloric acid. You have a combination. You need 100 milliliters of a 3%. Find how much of each solution you pour into the mix, okay? Okay, smallest is 1. It's going to be mixed with the highest 5. Come right in the middle, okay? Actually, this is, I think it's 50-50, but I might, because if it's right smack dab in the middle, it'll be 50-50, but I don't know. Let's make sure, okay? So milliliters, ml, then percent, 0.01, 0.05, 0.03. Okay, now the 100 milliliters is the 3%. So that's X, that's Y. So 0.01X, 0.05Y. 100 times 0.03 is 3. So X plus Y equals 100. 0.01X plus 0.05Y equals 3. Okay, so I multiply these all by 0.01 and these by 1. So 0.01X plus 0.01Y, and then you're going to get 1. And then 0.01X. You should not be doing it in your head, okay? They pay me to do that. You don't. Okay, make those bad boys all negatives, and these cancel. And I add 0.01 to negative 0.05, negative 0.04. And that's negative 2. So now I divide. And negative 2 divided by negative 0.04, that's 50, just like I suspected. So it's 50, and it's milliliters at 5%. Then you just, 100 minus 50 is 50. So X is 50 milliliters at 1%. Yeah, when it comes when the percent that you mix comes halfway, you're going to take the same amount out of each, okay? All right, last one. for extremely cold temperatures, you need a combination of 100% antifreeze solution and 50% antifreeze solution. You need 11 quarts of 70% antifreeze solution. How many quarts of each solution do we need? Okay, so again, mixing percents together. Highest percent is, lowest percent, sorry, is 50. Highest is 100, that's kind of weird. And then 70 didn't come in between, so it's different amounts from each bucket. Okay, now put quarts and percent. Okay. By the way, if you don't have a third percent, you're going to put total. I don't think that happens on the sign, but it does with the interest problems that I did. Here, let me dig it out of the trash. Okay. So like on this problem here, it gave me a 12, only 12 and 14, so I just put total right there. Okay, it's fine. Okay, so 0.50. And 100 is actually one whole, and then 0.70. Okay, now our quarts, that's 70%. Okay, so I can call this X and Y. So 0.50X and 1Y. And I take 11 times 0.70 is 7.7. So X plus Y equals 11, and 0.50X plus 1Y equals 7.7. So take 0.50, 111. So 0.50X plus 0.50Y. 11 times 0.50 is 5.5, and the bottom's just the same. 0.50x plus 1y equals 7.7. Okay, add them, those cancel. 0.50 plus -1 is -0.5y, and this is going to give you -2.2. So now I divide. Okay, and I got 4.4. Got a little decimal here, so it's 4.4 quarts at 100%. That means it's all antifreeze. There's no water in with it. That's what 100% means. Okay, and then I can take 11 minus 4.4, and that's going to be 6.6. X equals, you can also plug it in. Just trying to save you some time. At 50%. So when it says 50%, that means 50% of the bucket is antifreeze, 50% of it's water. Okay. Here it's 100% all antifreeze, no water. Okay, that's all I have to say on that. It's kind of weird, but that concludes mixture tables.